Alright, to solve this problem we need to dissect it first. Up here we have our claim. I win 75% of all domino games I'm at. Down here we have the evidence that can be used to assess this claim. The last time I played with April, I won only 13 out of 30 matches. We are then being asked if will it be enough to conclude that I'm lying, that the proportion is actually lower. The objective of hypothesis testing is, as the name may suggest, to compare two hypotheses. You may have heard about hypotheses in your science classes, where 33% of supposition or belief. In the statistical hypothesis testing, you are in fact comparing two suppositions you may form about an entire population. One of the hypotheses is called the null hypothesis. It will be according to my claim, in which I win 75% of all domino matches. The other hypothesis is the one that April's data supports, that my proportion is not as high as I claim it to be. We will calculate the probability of me winning 75% of all domino matches given April's data. The evaluation of our null hypothesis with the data is the purpose of this test. If this probability is less than our set significance level, then we can reject the null hypothesis, or in the case of this problem, we can conclude that in fact, I'm not so good as I claim to be. To calculate these probabilities, statisticians came up with a mouse-shaped figure called the standard normal distribution. In this distribution, the graph is marked according to some numbers. The numbers in the x-axis represent the distance from our data to our null hypothesis, which is 75% of 0.75, and these are called z-scores. The z-scores are calculated from our data, in this case April's, using a formula shown later. Keep in mind the probability is expressed as the area in the graph. We'll be checking three conditions before doing any hypothesis testing. First, the data needs to be normal. If you can't demonstrate the normality, then you won't be able to use the normal distribution. Basically, you have to show that you have 10 failures or 10 successes using probability as shown in this slide. Next, the independence condition serves to be sure that you can use the formulas used to carry out the test. However, in most cases, you will be able to prove this condition. In most statistical tests, you'll need to show that you sample less than the population. Random. Before doing any sort of hypothesis testing, you will have to show that the data were randomly taken, or subjects randomly selected. In this case, the infinite number of possibilities in which April's match 30 games against me could have resulted makes the data intuitively randomly selected. Now, this is the z-score formula I mentioned earlier. P sub O is our null hypothesis, and P had the proportion from April's data. Going back, we'll examine where our z-score holds, and then we will look at our alternate hypothesis to see how to calculate our probability. The alternate hypothesis is that P is less than 0.75, so you want to take into consideration the area in the negative direction from our null hypothesis. Then, you compute the area covered in the left side of your z-scores to answer your question, and then you can say that my claim is false.